All right, so also, ladies and gents, today is sort of like a lecture day. Tomorrow's more of a practice day. But tomorrow we won't be practicing the homework, if that makes sense. You will have homework today. I want you to practice it at home. And then after tomorrow's activity, maybe you can finish the homework if you were confused at something. All right, so the essential question: how do we solve a system of equations algebraically? First off, substitution. Let's go over some rules for substitution. First, you have to have an isolated variable. So, very first step, isolate a variable. I realize I'm writing it off to the left side. You may have room in your guided notes in the middle of those two examples, because with Cornell notes, we've got to remember to have that left side open for those questions. All right, so let's isolate a variable. You typically want to pick the variable that will be the easiest to isolate. Maybe has a coefficient of 1 or -1. So let's take that first equation and isolate y. So some of us may add y to both sides and then subtract 13 to where I get the expression 3y minus 13 being equivalent to y. I get this important expression. Now we're going to substitute that expression into the next equation for y. So in that next equation, I'm showing every step. Some of you may not need to show every step. So now as we solve for the both variables, we get an x-coordinate of 2. But we've got to recall, go to the beginning of your notes. You see that recall statement? Go to that recall in your notes. I forgot to include a slide here to that recall. It says recall. Hold on, let me read it. Recall. A solution to a system of linear equations is what? So in that recall statement, a solution to a linear system of equations is an ordered pair. That means we need both an x and a y. So now that we have our x-coordinate, we've got to figure out our y. So part of this solving for the variables, we're going to have to take that x-coordinate and plug it into our equation. Solve for y. We get the ordered pair 2, -7. So the easiest variable again, which is ironic, it's not always going to be the first y in the first equation. So to shorten up some steps, let's immediately solve for this y. What would that expression be? Second step, substitute. We're taking this 2x plus 6 and sticking it in where y is. Yeah, so what happens? We get an oopsies. This becomes 0. And we're left with -12 equaling 5. What does that mean? So when you get a false statement, this means we have no solution. Can we talk about what's going on? Okay, so we algebraically get a no solution. What does that mean about its graph? So that means these graphs of lines are parallel. They have the same slope. That's why we've got a no solution. So algebraically, we get a false statement. If we were to graph those, we would have parallel lines. All right, just making some sort of connection. Let's do the last one. So if I isolate x, x is going to equal y plus 3. We will then substitute. Another tricky one. These y's, getting them together, create 0, and I'm left with negative 6 equals negative 6. So what do we say when we have a true statement? Infinitely many solutions. So next, elimination method. We're going to go through the same 3 examples using the elimination method. Elimination is typically a quicker method whenever both equations are in standard form. Substitution is typically quicker whenever the variable's already isolated. All right, so elimination method, let's recall how to do it. First step is to create opposites. You pick a variable to concentrate on, and we're going to create opposites somehow. The way we're going to do that is multiply an entire equation by some number so that we create opposites. So pick a variable. We're going to create opposites for the y's by multiplying that top equation by 2. We're going to multiply each term by 2. So we get 6x minus 2y equals 26. We're going to combine that with the other equation. We're going to add those together. When we do that, the goal should be met. We should be eliminating a variable. If we do not eliminate a variable at this step, we've done something wrong. So eliminating, we get 8x equals 16. Divide both sides by 8. We immediately get the x-coordinate of 2. So the third step, after you add the equations, is now solve. Solve for each variable. We need to end up with an ordered pair in the end. After you get one of the coordinates, plug it back into something. So I typically just choose the first equation. 3 times the x-coordinate 2 minus y equals 13 and solve. Y-coordinate again is negative 7, which is great because that's what we got as our first answers. 2, negative 7. Create opposites by picking a variable that would be easy to multiply by to create the opposite. So again, the first equation, let's multiply the first equation by 2. It's not always going to be the first equation. It's not always going to be 2. But let's do it. So wait a second, when we did this before, we're hopefully seeing a pattern of, okay, wait, what happens when both of these go out? What are we left with? We're left with 0 on the left side equal to 17 on the right side. We get a false statement. So this is, again, in the same manner. If we're solving algebraically, whether we're using substitution or elimination, if you end up at some point with a false statement, you've got a no solution. So doing the same exact problem in a different way, no matter what. If we get a false statement, we get a no solution. So let's see what it'll look like with an infinitely many solution problem. And we notice, hey, wait a second, we've got 0 equal to 0 in this case. So in the elimination, if you end up with a true statement, you get infinitely many solutions. So last little get-go. We're going to choose the statement that's true. Either the quantity in A, or in column A, is going to be greater, or the quantity in column B is going to be greater. The two quantities are going to be equal, or we can't even determine. So we need to figure out the x-coordinate of the solution. Well, how in the world can we find it? We could try substitution. I'm probably going to do elimination. Since I already see opposite signs here, I'm going to multiply this entire top equation by a 2 to eliminate the y's. sometimes when you're given the problem, you can immediately just, you don't have to completely rewrite that step, if that makes sense. So 14x minus 2y, I'm going to write it below the other line. Add here, solve. Ooh, 72 divided by 24. I'm not exactly sure. Is that 3? That is a 3. So wait a second. The left column, the x-coordinate, does end up being 3, and so is column B. So the two quantities in this case are equal.